I'm live. So, yep, hi everyone and welcome to the stream. So, today we'll be discussing about the problems that were there in interview series 8. But before that, let me know how did it go for you guys? How were the questions? Did you like the questions? Was there any difficulty in solving the question? How were the questions? General was these things. Anything that like how did the contest go? Like were the questions good? How were the questions? How did the contest go overall? Tell me what questions were very good. Okay, right. Anyways, let's get started with the problems without wasting time. So the first problem, it's pretty simple. So it's basically balloon everywhere. So the question is, Bob is very fond of balloons. Once he visited an amusement park with his mother. The mother told Bob that she would buy him a balloon if he answers her problem right. She gave Bob a string S and asked him to use the characters of the string to form as many instances of the word balloon as possible. Return the maximum number of instances that can be formed. The only note here is that you can use each character at most once. Right. So basically, you are was able to solve the first one. That's fine. We'll discuss all the solutions. So the problem is pretty simple, right? Like you are given a string and you have to tell how many instances of balloon, the word balloon you can form, provided you can use each character only once. So for example, in this case, you have in this string, you have one occurrence of B, one occurrence of A, two occurrences of L, two occurrences of O, one occurrence of N. So you can form only one balloon, right? In the second case, you have two occurrences of B, two occurrences of L, four occurrences of L, four occurrences of O, and two occurrences of N, right? So in this case, you can form two balloons, right? Because you take one balloon and you will be left with one, two, two, one, which will again form another balloon, right? So it's pretty simple. Basically, like what you have to do is you have to find the count of every character. Then for every character, and note that L and O, these two are used two times. So their count will actually have to be divided by two, because each because they can, like, they need two of them are needed for every balloon, right? So you'll be dividing their count by two, and then whatever is the minimum one, that will be the answer, because like you cannot use more characters for that character, like that which is over, right? For example, let's say let's consider an example for this. So let's say B has a occurrence of 2, A has a occurrence of 3, L has a occurrence of 6, O has a occurrence of 6, N has a occurrence of 3. In this case, you can only form two balloons. Why? Because although all other characters can be actually used three times, like A, L, L, O, N can be used three times, but 2B can be only used two times, right? So the minimum of them will be the answer. So that is the solution for this. So yes, we'll need a hash map for this. Actually, not exactly kind of a hash map, like we'll use a frequency array. So we'll just create a frequency array, right? So frequency of 26, and initially everything will be 0, and for int I equals to 0, I less than s dot size, I plus plus, frequency of int of s of I minus a plus plus. So what we'll do is frequency of L is basically, let's just write down that int L minus a, L minus a divided by equals to 2. L and O will be divided by 2, right? So int O minus a divided by equals to 2, and finally int inval equals to frequency of b, frequency of 1, that is b. For int, okay, uh, it's better to write down, I think, in terms of use a hash map. It will be simpler. Definitely we can use a frequency array of 26, but I believe using a hash map would be much simpler than this. So let's just use a hash map instead of this, right? So unordered map char frequency, and here we'll directly write frequency of s of I plus plus, and here frequency of L and frequency of O, and min will be frequency of B, and then A. So string word equals to balloon, and for char x belongs to word, we'll do minval equals to minval and frequency of char, and finally return min. So that should do the trick. Return minval. So let's try to run this. Okay, frequency of O divided by 2. Have a bracket here extra. Let's remove that. Well, frequency of x, actually. I think it's working, so let's try to submit. So this is done, right? Pretty simple question. There's nothing nothing extraordinary here. We just like maintain the count of each of them, and L is used 2 times, so we'll just divide by 2. Again, O is also used 2 times per word, so we'll also divide O by 2, and after that we'll find whatever is the minimum one. That many times we can create balloon, right? Yes, yes, definitely 5 variables can be used. Why have I used a hash map here instead? It is just because it was easier for me to write the code. Otherwise, I have to write 5 if-else statements, right? Or 5 min comparison statements. So instead of that, I just preferred like doing it using a hash map just to make this code more readable or more simpler for me. Nothing else. Uh, Dry run once, sure. Let's dry run this on this example. So what happens, let's see. For this example, uh, L O O that. So let's maintain the frequencies. So L frequency here, first of all, we are going through all the characters and increasing their frequency. So L frequency is initially 1, then we will have two O's. So O frequency is 1, then it will become 2 because we have two O's. Then we have a N. So N frequency will be 1. After that we have a B frequency is 1. After that we have a frequency is 1. Then we have a L frequency is incremented to 2. After that we have a X frequency is 1. After that we have a B frequency is increased to 2. After that we have a frequency is increased to 2. After that we have two L's, so L frequency is increased to 4. Then we have P frequency is increased to 1. After that we have two O's, O frequency is increased to 4, and N frequency is increased to 2. Now what we want to form is balloon, right? So what we do, frequency, first of all we do is frequency L divided by 2. So frequency of L is what? 4 divided by 2 is 2. Frequency of O also divided by 2, so O divided by 2 is 2. Now we go through all the characters of balloon and find which one has the minimum frequency, right? So B frequency is 2, A is 2, N is 2, O is 2, L is 2. So everything is 2, so the minimum is 2. That's why the output is 2. Yes, the space complexity, exactly. The space complexity will still be order of 1 because the hash map only stores 5 elements, right? So there is no additional advantage that you would get or disadvantage that you would get out of a hash map versus five variables. It's just that the code looks much simpler this way. We're considering 2L as one, right? Yes, 2Ls as one, because each we are just computing how many balloons, how many times L can form balloons, right? So in one balloon you can have 2Ls, right? So that's why divided by 2, that is that many number of balloons L can support. Similarly, that many number of balloons O can support. That's why divided by 2, because in each balloon you will need two O's. No, order of n only when you stored n elements, right? Only when you stored n elements, the this will actually it depends on the implementation, right? How is the hash map implemented internally? If we can use a simple map as well, like something like a tree, and that will be like order of one, right? So that also works fine. So don't worry about these things. Like definitely when it is asked in your interview, maybe you can prefer using hashmap, or you can use a, in fact you can use an integer array of 5 and then draw the comparisons, something like that. You can definitely do that. You can index b to 1, and like that you can definitely do something like that as well. So it's just about making the code more readable, right? We all know like there are multiple solutions, but it's more about making the code more readable. Whole string input characters, whole string input characters, that will be 26. This will be giving us 26, right? uh, s dot length will be 10 to the power 6, but only lowercase english characters will be used, so this will be only 26, not more than that. Anyways, let's go to the second one. Let's go to the second one. So A B C A D B C A, and okay, so first of all the question, given a linked list of characters and a string s, return all the anagrams of the string present in the given linked list. In case of overlapping anagrams, choose the first anagram from the left, right? So we are given a string s, and we have to return all the anagrams of the string, uh, return all the anagrams of the string present in the given linked list, but they have to be disjoint again, right? So anagram means what? Anagram means any arrangement of the characters, right? Any arrangement of the characters, whatever arrangement of the characters, it doesn't matter. So you have to return all the anagrams that are present in the list, in the linked list of characters. Only constraint is that if you choose a character, you cannot choose like the character again. Like there should not be overlapping anagrams, right? For example, if you consider this case, ABC AD BCA, and the string that is given to you BAC, right? So what are the anagrams possible? Any anagram, ABC, any permutation of BAC is an anagram. So ABC, CAB, CBA, everything is possible. So for BSc, let's see. So ABC is matching, right? ABC is matching. Again, BCA is matching, but see, there is an overlap between them, right? So we'll choose the first one. So we'll choose ABC, right? After that, there is no match here. Finally, there is a match BCA. So we choose BCA as the second one. So we return to ABC and BCA. What if the number of L and O is odd? If the number of L and O is odd, it will be rounded down to the nearest integer. So let's say there are three L's, right? So only you can form one balloon out of them. You cannot form two balloons, right? So it will be rounded down to the nearest integer. That's why division works well. Like it will be rounded down to the nearest integer. Okay, so ABC, BCA, there is overlap between this, so we'll choose this one directly. So there are two of them, right? Similarly, ABDCA, there is no anagram present of BSC that is available here, so the output is -1. So that's the question, right? That's the question. Now let's understand how do we solve this, right? So ABC, AD, BC. Let's see. Right. So here, what do we need? We want to find all the anagrams of BAC, right? Let's call it BAC, right? All the anagrams. Now, anagram, whenever we talk about anagrams or any permutation, what we mean is we have to see if the frequency of the characters is same, right? If the frequency, like here if you see the frequency of ABC, what is desired, the frequency of ABC desired is A equals to 1, B equals to 1, C equals to 1. This is what we desired, right? But we have to see if the frequency is same here as well. So ABC, the frequency is indeed same, right? So that's why we refer to this as an anagram, right? So whenever we are talking about anagrams or when we are talking about permutations, in most of the cases we'll just deal with the frequencies, right? We'll not deal with the string. Just forget about the string. Just think we have to find if there is one A, one B and one C in consecutive fashion. That is what the question has reduced to. The question has reduced to whether there is one A, one B, one C in consecutive fashion in a subarray, right? So that is what the question has reduced down to. Now what we'll use is we'll use something like a two pointer approach, right? So first of all, we'll have two pointers. We'll have two pointers with us. So the first pointer will be here. The second pointer will also start here. Now we have taken A, right? So we'll maintain a frequency map as well for us. So frequency of A is incremented to 1. We have taken A and we'll move the right pointer. Let's say this is the right pointer. We'll move the right pointer by one place. Okay. B, we have taken B. B is 1. And we'll also check we'll also check, that is, if we have formed the ABC, if we have formed anagram of the string, that is otherwise it was supposed to be plain count, so 0 in case of right, yes. So B, again for B, we see that the count is 1, right? For B, what do we see here? Again, what do we see here? That B, the for B, like AB, uh, we increment the count and we see, like, we compare with this. So what we'll compare is whether the count of the characters that we have, they match completely with BAC. If they don't, if we have some new character, let's say, which is not there, and these cases, in those cases we should do something about that. So that comes in later, but B count is incremented by 1, right? Let's go to the next character. So it is still not completely matched, right? It is matching but not completely matched because C is pending. So we'll go to the next character. We have C. So C frequency is set to 1 and we see that there is a valid match. So we'll increment our answer, right? We'll add this to our answer. So to the answer ABC is added. To the answer ABC is added. After that we go to the, but before we go to the next B, see, we have completed something, right? Rather, we'll go to the next B. We'll go to the next B and we'll increment B to 2. Now when we increment B to 2, we see that we are exceeding the limit. So definitely we have to remove something, whatever we have chosen till now, whatever is the current window that we are at, what is the window, current window, ABCB that we are at, whatever we have chosen till now, we have to give up a few of them because we have exceeded the count of uh, B, right? So we'll start moving the left pointer then. So left pointer is moved by one place. So what is getting away? A is getting away. So we'll decrement the count of A by 0. Is it still not matching? Yes, it is still not matching. Count of B is more. So we'll again move it by one place. Now what is going away? B is going away. So B count will be reduced down to 1. So now we see that A, B and C count is matching. So this is valid, right? So we will again start moving the right pointer. Right pointer is moved by one place and A count is increased to 1. Again, we have a match. We have a match here, right? Uh, Actually, whenever we have a match, right? Actually, whenever we have a match, we will directly go to the, because we cannot take overlapping ones, right? We cannot take, also we can check here as well. We can check here as well, or it's better, like, whenever we have a match, we can directly start our search from the next position because we cannot have anything starting in these places, right? So both will work. Like in this case, you will just maintain what is the ending point and you can check for overlap as well here, that hey, this is overlapping here, right? So you will not take that. That will also work, or you can definitely start your search from the next position. But this is important. Like, why have I come this way? I could have directly gone here and started the search, but why have I come this way is, let's say you have some unknown character in between, right? I think it's always better to directly move, because even if you have unknown characters in between, not unknown, rather, let's say, let's call this A, right? Let's call this A. So I'll show you why this was important move. Let's actually modify this a bit. Let's make it A here. ABA, ABC, right? Now see what happens. We had at A, so let's erase everything here. A, we are at A, our count is 1 initially, and our left and right pointers. So right pointer is moving B. B's count is 1. Now we go to A, we increase the count to 2. Now we see that we are exceeding the limit. A, we needed only one of them, but we have two of them, right? So when we have two of them, we'll move our left pointer. So we'll move it. Now what is going away? A. So we'll decrease the count of A. Now we are at a valid count. So when we go to the next position, we have B again, right? So we have B again, the count of B increases to 2. Now again it increases to 2, that means we have exceeded the count because we needed only one B. So we'll again move to the next place. So we have a, right? We have a here, so A's count will be increased to so B is going away, so B is going away, B's count will be decreased to 1. Now we have again valid count, so we'll move our right pointer, and now we have a C, so C's count is increased to 1, and we see that there is a match, right? So we'll add this ABC, and whenever there is a match, directly start your search from the next position, because there can be no overlaps, right? So directly start your search from the next position as if that was the beginning of the string, and use the same algorithm again, right? So whenever you have D, right, now D doesn't match with any character, right? So definitely whatever you have taken till now, whatever you are carrying forward is of no use, because in between you have a unknown character or an unused character, which is not there in BAC. So just again start the search from the next place, and everything will be reset to 0. So again BCA will be making it 111, and you have BCA as well added to the list, right? So yes, right. So this is the idea, right? This is the idea. So there are three cases, right? So we are actually ending up with three cases, actually four cases, right? Or maybe more than that. Let's see, five cases. Okay, let's write down the cases first, right? So case one, not completely matched yet, right? So not completely matched yet. So in this case, RPTR will just do RPTR plus plus. Case 2 is different character. A different character is obtained, right? Different character. So in this case, what we'll do RPTR plus plus LPTR equals to RPTR, right? RPTR plus plus LPTR equals to RPTR, that is you are starting from search from the next character, because we have a different character, so in no ways you can form a substring with only those anagram characters, right? So that's case 2. Case 3 is what? Case 3 is exceeded count. Exceeded count. So whenever you exceed count, what do? You increase your left pointer plus plus, and definitely like decrease the frequency of the corresponding character. Case 4 is match. Update answer. In case of match, you update answer, and then you do RPTR plus plus and LPTR equals to RPTR. You start from the next position. So these are the cases that we have, right? These are the four cases that we'll have. So let's try to write the code for this. Okay, so let's go this. Find anagrams head and s. Okay, so we'll maintain the frequency in frequency, and it will be of size 26, and initially it will be, in fact there will be two frequencies, right? And current frequency, or let's call it window frequency. Let's call it window frequency 26, 0. So first frequency is for the string that is given to you, for maintaining the count. So for char x belongs to s, you are going through all the characters of s, frequency of int of x minus a plus plus, right? Now we have the window frequency, we have to use the window frequency. So node star. Also secondly, what we have to do is we have to have some case here, right? uh, we'll do that something. Let's do it here only. So int return case. return case, we'll have the two frequency arrays. So int frequency 1, or let's call it frequency, and int window frequency. We have the window frequency and the this frequency. So for int I equals to 0, I less than 26, I plus plus. Okay, first is if in window frequency, if uh, let's consider the cases, right? First is a completely different character is introduced. So if frequency of I is equals to 0 and window frequency I is greater than 0, let's call this case 0, right? Let's call this case 0. So let's write down the definition of the cases here as well. So because we will have 5 cases, so case 0 is different character, that's taken care of, right? Second is, let's take care of increasing count. So if frequency of window frequency of I, if window frequency of I is greater than frequency of I, then return 1. If for any case 1 exceeds count, you should return 1. Third case is if it is less. So window frequency of I is less than frequency of I. Okay, actually after 0 and 1 we should come to the other cases, right? uh, or rather 0 should be taken care separately, everything should be taken care of separately, right? So first 0 should be there, like 0 should have the maximum like maximum weight. If there is any different character, just return that, right? So I equals to 0, I less than 26, I plus plus. So if and then comes the first case, right? First case return 1, that if any count is greater, right? So just return 1. Second is lesser case, I equals to 0, I less than 26, I plus plus. If window frequency of I less than frequency of I, return 2. So case 2 is not matched yet. Otherwise case 3 is matched. Return 3, case 3 is matched, right? Case 3 is matched. So we have the 4 cases with us. So let's maintain head equals to what? Head equals to the node star first pointer, or right and left. Right equals to head and left equals to head. Right equals to head, left equals to head, and yeah, we can maintain vector node star answer. And then what we can do, answer. So we'll go through all the characters. So while right is less than, we have to mark the end as well, right? We have to mark the end of the that as well. So node star uh, list end equals to head, while list end of next not equals to null, list end equals to list end of next, list end equals to list end of next. Why did you not write single case in single loop? Very good question. Why did I not write? Just imagine a situation. Let's say, see, whenever there is a different character, right, you should directly move to the next place whenever it's introduced. Let's say there is, let's say we have something like this, that B, frequency of B B is there, right? Let's say B is there and the frequency of B is greater than frequency of I. Although that should have been written, but yeah, like less case can come in, right? Frequency of B is less than frequency of I. In that case, it might return 2, right? It might return 2. So these two actually can go together, I believe these two can go together. But again, like just to be safe, for from those situations that frequency of b is let's say less than frequency, the window frequency, or window frequency is less than the current frequency, but later there is a character which is not present in frequency but is present in current window frequency. So for those cases, it's better to separate them out, right? Although I believe these two can go hand in hand, but definitely this cannot go with them, right? This cannot go with them at all. So right, while right is less than listen, okay, right is less than listen. So what we'll do is, also here we are at head, so we'll add that to our frequency as well, window frequency. We have integer here. Why do we have integer here? uh, I don't know, the structure doesn't look good. Yeah, like have probably we have, let's just follow that only. So window frequency right of data to plus plus, right? Right of data is equal to plus, and right less than this. So what we'll do is, uh, we'll decide our next move based on the case, or let we can just make the next move. So we can just make the next move. I'm just thinking of a single character case, like when there is a single string is of one character, right? S is of one character, that should also be handled. So window frequency. Let's go to the next place and update the window, right? Yeah. So what we can do is, also we can maintain our answer here. If answer if answer dot hmm, if answer dot what answer dot if return case frequency and window frequency is equals to 3, then answer dot push back head, right? Answer dot push back head. So we'll do right plus plus, we'll do right plus plus, and after that we'll do uh, right plus plus, and after that what we'll do, window frequency of right of data plus plus. So in case equal case number equals to return case frequency window frequency. If case number equals to 0, that is different character is available, so different character is there. So there is no point of comparison, like just go to the next place. So rptr right plus plus, yeah, right plus plus, and left pointer are left, or rather left equals to right plus 1, and it will get introduced in the next, right plus plus will anyways every iteration. So left equals to right plus 1, right of next, right of next, and this will be right equals to right of next, not right plus, right equals to right of next. Left equals to right of next, we'll just go to that, and case number is 0, and that should be, and also we should clear that is. So fill window frequency plus 26 with 0, all zeros, right? Similarly, else if case number is 1, that means we are at exceeds count case, so we should we have exceeded the count, so we should give up something. So while uh, LPTR is less than RPTR, less than equal to RPTR, sorry, not called LPTR, right? Sorry, left is less than equal to right. Left is not equals to right, rather not equals to right. While left is not equals to right, in that case, and find case of frequency and window frequency is equals to 1. What we'll do is window frequency of left of data minus minus window frequency of left of data minus minus window frequency left of left equals to left of next. And here, if left not equals to right, as long as it is 1, we'll do if find case frequency window frequency is equals to, if find case is equals to, let's say 3, we have to add this to our answer dot pushback left, dot pushback left, right? So that's case 1. Case 2, else if case 2, like if it's the normal case, else if case number is equals to 2, in this case what we'll do, in this case we'll just what we'll do, normally we'll just do nothing, so continue, we'll just go to the next place. Else case number is 3 finally, in that case we'll add it to our answer, so answer dot pushback left, and left equals to right, left equals to right of next, and return answer. So we have this, and if definitely if answer dot size equals to 0, we have to return nodes, right? Answer dot size equals to 0, answer dot pushback new node with, let's run this, node star right equals to head होगा, p right equals to head, and left equals, member function moment, answer is what, vector node star has no, what do we have, pushback, we have push, where are we pushing, turn key, pushback base. Find case was not declared in scope. Return, okay, let's call it find case. Find case. Okay, here we have used return case. Let's find case. answer dot push back return case was not declared in the scope 9. Here also the fine case. Lot of complication you ABCA returns. That's interesting. ABCA case number is fine. First of all, let's output the case every time. Out case number and let's see the case numbers. 222. It's always 2. A B C. C should not be 2, right? C should not be. Why? Because window frequency of I is less than frequency I. We have C, right? We have C as well. So A B. Let's see that. Okay. Let's actually print the data as well. Write of data is not an integer. It's okay. Correct. So write of data is represented by the ASCII value, right? So it should be minus 90. So whenever we do this write of data, we should do minus 97. That should be fine. 97, and again here also write of data minus 97. I think here also we have to do somewhere left of data minus 97. Let's search for data. Go through all the data minus 7, data minus. I believe we covered all of them. So let's run. ABCA. Put ABCA is the output. Why is ABCA the output? Case number 2, ABC, once it is matching ABC. Case number 3 comes here, left equals to right of, and answer also has to be. Let's clear this. Answer is cleared, so clear this answer. It has to be cleared here. I think it has to be cleared here. Now this should be ABC. Voice, is the voice low? Can anyone tell if my voice is low? Answer dot size. Okay, fill. This is also not. Let's see. So what should be the case numbers, right? Let's print the case numbers. Case number 232. 23. Why is it pushing in 2? Yes, 232 is valid. 232 is valid. Yes, 232 is valid, but it is pushing AB somehow. What do we have to? Which takes head, turns an array of link. Array of linked list. Okay. Okay, we have to create a new link list. All right, got it. So we have to create a new link, private, the private node star generate anagram. Let's call it generate anagram, and we'll have node star head, node star head, yes, and int length I equals to 0, or rather node star left to that node. Let's take both left and right. Left to node star right, and node star current equals to left. Rather new node while left not equals to right, left not equals to right, current of node star head equals to current, current of next equals to new node, left equals to left next, left not equals to right. For right it will not work, yes. Left equals to left next, current of next equals to new node, left of data, and return head. So here we'll push answer dot pushback, create anagram, left right. Here also we'll push answer dot pushback, generate anagram, left right, answer dot pushback, generate anagram. So let's run this now. AC also acting weird once case number. Let's not see out case number. Let's see our find anagram, generate anagram, left to right, current equals to new node left of data, node head, while left not equals to right, left equals to left next, current of next equals to new node left of data. B is getting uh, left to right, so left is the pointer to this node, and left of, we're going to left of next, so from A will go to B, right? From A we will go to B, and current of next equals to new node left of data, turn head current, and current equals to current of next, current equals to current of, so we are not moving, that should be. Let's run this. Let's try the sample. ABC is working now. Let's try this case as well. AD 4, I believe, 1 2 3 4 5 5 A B B C and BAC. Let's print my output, and also we'll try the first case as well, just to be sure. My output is 3. If answer dot size is equals to 0, yes. Answer dot pushback new node. Okay, it sees a -1. Answer dot pushback new. That should be. Let's find the expected output. Okay, it's printing that. Why is my answer dot size not equals to 0? See out answer dot size. Don't we need to have generate check for left null? Uh, Check for left null. check for left null. We are never actually moving to null, right? So we should not, we don't need to have that check. Okay, answer dot pushback. So I'm pushing back new node minus one, right? Is it not getting value? New node, we are pushing back, and not sure why is it not taking that. Sorry, node star new node equals to new node dot pushback. So the size is 0. It is indeed 0, and we are creating a new node. So minus 1 should be 96. Code for this question, you will definitely get a lot of them under submissions. Okay, it's not 96 definitely. It should be minus 1. Minus 1 in ASCII. What is minus 1 in ASCII? It's converting to how do I write minus 40 40? Not sure how we can print minus 1. I believe that should you know, 47 is also minus. Let's have it minus. And let's run the first case. I don't think this will be executing because I'm not sure how are we, or can anyone help me, how are we printing minus 1? B A C 1 2 3 4 5 6 8. We have 8. Oh, okay, you are entering the character value ABCBAC. I think it is working fine. Let's enter the character. I think that also makes sense. Yep, that makes more. Let's just compile and run. That should be fine now. Let's run. My code output is minus 1 is not uh let's do something in this int of my, let's take this example. Sure, how they are print. My code is giving 1 for minus 1 as well. uh Not sure how I can. Should be available under submissions. I see. If you go into this submissions and maybe coding problems, let's go to this one. Go to submissions, you can see. Okay, you cannot, only my submission. You can have my code, like I'll just give the, I'll just create a pip link. Let's okay, let me just code. You can try the minus 1 case dot if. Also write it down. Write I'm not copy the code. Okay, write on the sorry, control S. Write on the link, small o, capital N, 6Z. Small o, small o, capital N, 6Z. This should be the link. Small o, capital N, 6Z. Small o, capital N, 6, right? p.ip.fi slash small o, capital N, 6. That should be the code. Anyways, -1, I'm not sure how do we print -1. I'll have to check how is it printed, but yeah, like uh, that is not working. Let's come to the last one. Yep, the last one is it's a it's a good question. So Elena is yeah, provided with the code small o, capital N, 6. Let me see if I can write it here. Type dot ip dot. Correct. So let's come to this question, the last question. Elena is the topper of the class. Once a teacher asked her to solve a problem. He gave Elena an array of integers of length n. He calls a subset of array ARR good if its product can be represented as a product of one or more distinct prime numbers. He asks her to find the number of different good subsets in ARR modulo 10 to the power 9 plus 7. Right. So okay, so okay, so that's the question. Now what is the question exactly? See, we have four integers, right? So we have to find how many subsets are good, how many subsets of the array are good, what is the good subset, the product, when you like the product of each of them will create one or more, is the product of the all the numbers that you have taken in the subset, that should be a product of one or more distinct prime numbers. Like for example 1 2 3 4. Say in the subset you choose 1 2. That is, it is a, it is the product of 2, right, which is a prime number. So 1 2 is a valid subset. 2 alone is a valid subset. 2 3 is a valid subset because the product is 2 into 3, both are prime. 1 2 3 is a valid subset, 1 3 is a valid subset. But see, 4 cannot be included in any of them. In fact, 4 alone is also not a valid subset because 4 is a product of 2 into 2, so 2 is getting repeated, right? So you have to select a subset such that none of them are repeated, none of the prime factors are repeated in their product, none of the prime factors are repeated, right? So that's the question. How do we solve this? So whenever uh, maybe it's more, in most cases it's the fact. Also constraints also help you in these cases, right? So if you look into the constraint, right, if you look into the constraint, ARRI is 30, ARRI is 30. So constraints are very important. Why? See, what we will do here, ARRI is 30, and what we have to maintain is distinct prime numbers, right? Distinct prime numbers. So whenever we have generated a subset, right, just think about it, how to maintain distinct prime numbers. Whenever we are generating a subset, we should know what is the set of prime numbers that are already there. Like let's say 2 is there, 3 is there, right? So let's say the current element is 9, 9 is, or let's say the current element is 21, 21 is 7 into 3. So we know 3 is already there in the subset. You cannot include 21 because 3 will become a duplicate, so that will violate the condition that is placed, right? So we do not want duplicate, so we need a way to maintain the distinct prime numbers, right? And one way to maintain them is using, like whenever you have to maintain what are the values you have taken, one way to maintain that is bit masking. One way to maintain the values that you've taken is bit masking. So let's understand, can we do bit masking? What are the prime numbers till 30? All the elements are within 30. So 2 3 5 7 11 13 17 19 21 will not be the 23 20. 29. So these are the prime numbers. How many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 prime numbers are there. If you do bit masking, it will be 2 to the power 10. Right? That will be approximately, that is 1024, which is approximately 1000. So 1000 into 10 to the power 5, approximately 10 to the power 8, which is within our constraint. Right? So we can do bit masking. How do you get bit masking solutions? Because see, we have to maintain distinct prime numbers, right? We have, so when you are selecting an element, so let's say this is the set, this is the subset that you have formed, right? This is the subset that you have formed till now, and this is the current element that you're considering. So can you put this in the subset? How will you decide? You will decide with respect to the fact that what are the prime numbers that are there, what are the prime numbers that have already been taken. Let's say 2 3 are already taken. So if your current element is 21, which is 7 into 3, you cannot take that, right? So there should be a way you can maintain the list of elements that you have already taken. And one way to maintain these things, like the elements that you have taken, is using bit masking, right? Using bit masking, you can maintain the elements that you have taken. Why did you multiply with 10 to the power 5? Because we will do a DP bit masking solution. Like we are generating the set, right? So I already had that in mind that we are going to do a DP bit masking. So that's why I did 10 to the power 5. But again, like you know that there are 1000 possible bit masks. So whatever technique you use next, you have to multiply with 1000, right? Whenever you go with bit mask. So coming to the solution, let's say fn comma mask. What is fn comma mask? If n comma mask is the number of subsets, the number of subsets we can form from the first n elements, provided we already have taken a few prime numbers denoted by mask, right? So mask, let's say mask is something like this. Let's say mask is 3. 3 means 1 1 mean binary, 1 1 means 0th and first prime numbers are taken, that is 2 and 3 are taken. So in that case the mask will be 3, right? 2 and 1 are taken, that means the mask will be 3. So it will represent what are the prime numbers that are already taken, right? So now with respect to mask, what you can decide, like you have to first decide whether you can take some element or not take. When can you take some element? When the mask and the current element ARRI, the mask of the current element, mask of current element, that is mask of ARR of I, when the mask that you have and the mask of ARR I, they do not have a common set bit. If they have a common set bit, that means the prime number is getting repeated, right? So you cannot take. So common set bit, they do not have a common set bit, that means their AND should be equals to 0. So when mask and the mask of the array element is 0, then you can take the array element, then you can take, or you can decide not to take as well. You have two choices: either you can take the nth element. Okay, you do not, we can just return the answer. If it is empty, it will print -1. Let's try that. I thought we have to print minus. All right, let's try that then. Okay, something is wrong here. I'll have to check again, but yeah, like the logic will be similar. You can definitely try to do it. So anyways, let's go to this question which we were solving. Okay, so mask with the ith element, with the ith element, with the nth element. So nth element, like you have already taken a few elements, right? You have already, like you have elements, you are at the nth element and you have already taken a few more there are already more elements on the right and you have taken some of them. What matters is what are the prime numbers that you've taken, right? What are the prime numbers? So that is represented by mask. Mask is the prime numbers that you've taken from the right hand side. So you cannot take these elements again. uh, what is mask ARRI? uh, Mask ARRI. Okay, mask ARRI means you are generating the prime factor mask. Like let's say we have an element called 3, so the mask of this will be 1 0. 1 0 means that is equals to 3. Let's say you have 2, so it will be 0 1. That is 0 1 is uh, 2 to the 0, that is 1, right? 1 0 is 2, rather, sorry, 1 0 is 2. So you have a number like let's say 6. 6 is 3 into 2, so it will be 1 1, right? Basically, zeroth bit. So what are the prime numbers? We have seen the prime numbers, right? 2 3 5 7 11, like this. So this is zeroth bit, this is first bit, this is second bit, this is third bit, this is fourth bit, and like that, right? So whenever 2 is available for the element, uh, for the array element, if 2 is a prime factor, so the first bit will, zeroth bit will be set. If 3 is a prime factor, so the first bit will be set. If 5 is a prime factor, so the second bit will be set, and like that, right? So this is basically, this is the array mask. This is array mask. The masks that you generate by generate from the prime factorization of the array, right? That is array mask. So and one thing to note, you will never take elements that are like, you can just get rid of elements that have similar prime factors, right? Like 4. 4 has two twos, so you will never include 4 in your answer, so you can just get rid of those elements, right? So the first thing that we'll do is get rid of those elements whom we cannot take at all. So, or rather, you can do that in DP as well, just never take them, right? So DP in mask, the current mask that you have, if you can take the element, what is the condition again? The condition again for taking an element is add a mask of I, and mask should be 0. That is, they should not have a common set bit, right? So DP n mask, if you can take the element, it will be DP, you can either take it, so n minus 1, you can either take this, so mask, and uh, mask, and you definitely, you have to like update the mask. Update mask means you have to update the prime factors, right? So the prime factors of the current array element also gets added, so array mask, mask or array mask. So you are basically updating, like you are setting the zeros to ones as well for the current element that you've taken. Array mask plus plus dp, you don't take it, so if you don't take it, it will be n minus 1 mask, right? You don't take it, it will be n minus 1 mask. uh okay, it will be n minus 1, and dp of 0 0, uh dp of 0, you don't have any elements to take, and mask, let's see, you have some mask, you've taken some mask, is 1, because you don't have any elements to take, so that's a valid subset that you've generated. So dp of 0 mask should be equals to 1. And also dp of 0 0, if you do not take any element, right? If you do not take any element, that should be equals to 0. That is, the mask will be 0 in that case, because you have not taken any element. So dp 0 0 is 0, dp 0 mask is 1, and dp n mask will be dp n minus 1 mask, or ARR mask I, because again, like you have to update the mask with the prime factors that you've taken, plus dp n minus 1 mask. You don't take it, right? You don't take it. So that's that's basically the solution. So let's try to write the code for this. So mask is actually increasing, right? Good observation. So first of all, we'll get rid of the elements. So vector in proper elements, or vector int, let's call it a, and vector int, let's create the array masks as well, arr mask. So okay, and let's maintain the prime factors as well, right? Let's maintain the prime factors as well. So vector int, sorry, int prime factors, or let's make it as a vector as well, vector int prime factors equals to 2, 3, 5, 7, 11, 13, 17, 19, 23, 1, 2, 4, 5, 8, 10, 10 elements. 10 elements. So also one more thing about, think right, one is but if you have a one, that will be, if you have a one, you cannot take one alone, that should be fine. Got it. So yep, vector int, so we have dp, right? So first of all, for, we'll go through all the array elements. Int I equals to 0, I less than n, I plus plus. So if a of I, if a of I is, sorry, if arr of I is equals to 1, then in that case a dot pushback 1, and arr mask dot pushback continue. Int mask equals to 0 for, and also bool duplicate prime, if prime is available 2 times. For I equals to 0, sorry, while for int pr belongs to prime factors, right? Prime belongs to prime factor, so we'll check if what, if arr I, if arr so rather while and int count equals to 0, while arr I modulo prime equals to 0, arr I divided by equals to prime, and count plus plus. So if count is equals to 0, right? Rather than this, we'll go through a normal loop only. For int j equals to 0, j less than pf dot size j plus plus, int prime equals to pfj, right? If count equals to 0, we'll just continue. Else if count is equals to 1, we will just add that to the we'll add that to the mask or equals to 2 to the power mask or equals to 2 to the power j. Else if it is more than 1, in that case we'll mark duplicate prime equals to true. So if not duplicate prime, only then add it to the answer. So answer a rr masks dot pushback mask a dot pushback rri. So we have generated the array masks, right? And now int n equals to a dot size, and int dp n plus 1 and 2 to the power 10, right? So dp00 equals to 0 for int I equals to 1, I less than 2 to the power 10, I plus plus dpi uh, dp 0 I dp 0 I equals to 1. Also we have to do modulo mod, right? So constant mod equals to constant mod equals to int 10 to the power 9 plus 7. So for int I equals to 1, I less than equal to I plus plus, for int mask equals to 10, we have 10 bits, right? 0 to 9 we have 10 elements, so 2 to the power 10 minus uh, mask less than mask greater than equal to 0, mask minus okay. So if dp so dp I mask is equals to 0 if, right? So if what if dp if mask if mask and arr masks of I minus 1 is equals to 0, in that case you can take it. So dp I mask is equals to dp I minus 1, take it, and mask, or as you've taken this mask or arr masks of I plus dp, you don't take it, I minus 1 mask, else dp I mask equals to dp I minus 1, and here you have to do mod as well. So modulo mod. Finally, what should be the answer? Return um, return dpn. Initially it should be 0, right? Initially you have not taken 0. Return dpn 0 should be okay. Here there will be I minus 1 have we taken, there are masks I minus 1 dpi mask, and that should is this the only approach? I believe this, I don't know if there can be it, but no, I would go with a dp. I don't know, I think this is the only way to solve this problem using bit masking. Not sure if what any, there will be a few errors, I'm pretty sure. Error masks was not declared in the scope, so that's fine. I will do error masks, it's error mask, that should be there. Also, what was the another error? In shadows parameter n. Okay, let's call this, instead of n, let's call this n, capital N, or let's actually call this n, and let's call this capital N, right? So here we'll just have to do capital N. So let's, I'll come to that. Let me just quickly see if my ob.good subsets. What is the issue here? As I've changed this to capital N, it is not anymore. Okay. So have this, let's have it capital N. So that capital N, capital N. Class solution has no member named dot good subsets. Okay, ob dot good subset. Output was 6. What was the output actually? It was 6 indeed. 2 to 3. Let's try 2 to, so 3 2 2 3. My output is 5. Let's see if it is 5. Let's try to submit this. So this is a runtime error. Let's submit again. Okay, it's going for a segmentation fault. Here 30. I believe because of size subset, and here we are taking integer plus 1, right? Place where we can go for this. So ARR a dot pushback 1, ARR mask dot pushback 0, that's fine. Mask equals to 0, get prime false equals to 0 less than plus plus, while count 0 count 1 count 2, that's fine. N equals to a dot size, n equals to a dot size dp00 equals to 0, right? Okay, so let's make this instead of int, let's long long, right? Long long, finally we'll have an integer. So dp00 is for 9 plus 7 dp. It's definitely going, it's probably going that they want 4 5 6 7 8 digits, probably going out of bounds, or so close to 0. So long should be a size more. So I equal to ni plus plus, that's also I believe is fine. We've taken a dot size and is 0. There are 10, right? There should be 10 elements. Let's see, 0 1 2 3 4 5 6 7 8 9, up to 9. Index 9 is there, so it should be 10, like should be 2 to the power 10, right? 2 to the power 10. So 2 to the power 10 minus 1, mask and error mask equals to 0. That case dpi mask or error mask have dp as long long. Can we have error right to be? Let's take the first few elements. One, two, five, 7, 10. And let's print expected output as it's same output, expected output. Let's have all the 30 elements: 1 2 3 4 7 8 10 11 13 15 16 17 18 19 20 21 3 6 20. Let's see if this works. My output is 3328. Expected should also be the same. Okay, expected is different: 6654. 3328. Okay, we are missing on some. For we cannot take elements whose which has a repetitive prime number, and definitely that's what we are getting rejected of. Also, other elements, any other element other than 1 will have a prime factor, so we are rejecting everything will have a mask reader. So let's see, mask 2 to the power j, j equals to 0, j less than p size, prime is p of j, while arr I mod prime equals to 0, arr I pi equals to plus count is 0, continue, it's not a prime factor, count is 1, mask will add it to the mask, or rather let's do it, plus equals to 1 to the power j, else duplicate prime is 2, if not duplicate prime, arr masks are pushback mask, and a dot pushback arr dp0 n plus 1 to the power 10, dp0 0 is 0, dp1 to the power 10, dp0 I not 2 to the power 10 minus less than equal to 0. Right here we can actually have 2 to the power 30. We can have at max 2 to the power 30 subset power 30. So this should have worked. Mask equals to my mask greater the mask minus minus dp I mask equals to 0, dp I mask or rr mask minus 1 plus dp I mask I minus cannot take it, so it will be I minus. Finally answer. So initially we do not start off at in we have 0 mask, right? We have not any prime factors, so that should be my output is coming different, right? 3 3 line 55. Oh right, line 55 should be capital. Try this now. Anywhere else I've made the same mistake, so let's see. This changed, still doesn't change. The answer is definitely not working. dp0 equals to 1. 2 to the power number of ones. Ones can ones be taken? Like I don't think ones can be taken. Can they be taken? Here do we have one alone? product of one or more good distinct. So ones cannot be taken alone, one has to be taken with some other thing. One cannot be taken alone. That's why we have set dpi 0 to dp 00 to 0, so that we should not take one alone. One should always be taken with something else, and otherwise for every other thing dp 0 I should one, because we have taken some mask, right? We have taken some prime factors. That's why it should be 0. Okay, are we actually interesting question. Are we okay? So for everything we're actually take or not, we're kind of always taking. We're kind of always taking. So we can start actually by taking from any element, right? So answer equals to 0. Rather long. Actually, I think I have understood the problem. Long answer equals to 0 for int I equals to 1, I less than equal to n, I plus plus, rather capital N, answer equals to answer plus d I 0 mod turn on. Have that case we do not take that element, so that should have been included, but let's see. This should not give the answer, although yep, this should not give, because this is already included here dpi minus. Ideas where I might be going wrong? To the power should be multiplied. Okay, to the power number of ones multiplied with what? So you are saying my answer is differing by 2. So if I do turn n into 2, that should give my answer. So we can take it, or we, yep, that's true. Although we have not removed 1. So we have not removed 5 6. Might be the case. Let's actually try to do 6654. So we should remove 1 actually. That should do the trick. 2. Yes, 2 will be definitely replaced with a count of ones, per count of 1. But here it is 1, so let me just test it. Should be there, 1 there already. 1 can be taken once if added or not added. Okay, let's say we have a certain number of ones. We can just add them. For ones, we can either, for any subset that we have generated, we can either, like, let's say we have 5 subset, we have 5 valid good subsets. With them we can either add 1. So 5, we can either add 1 or not add 1. So for each of them we have 2 possibilities, so each of them generates 2. So 5 into 2 to the power 1, or rather number of ones that are there. So for each of them, or we can take actually any number of ones. Okay, so the idea here is, like, if we separate out ones, that will be a bit challenging. So let's say we separate out ones, right? So we have 5 good subsets. So subset 1, subset 2, subset 3, subset 4, subset 5. Now we can add any number of ones to them, right? So we can add 0. So this can take 0, 1, 2, 3, 4, 5. So similarly, this can take 0, 1, 2, 3, 4, 5. For each of them, we have uh, six choices. So 6 into each of them we have, so number of count plus 1 into count plus 1, uh, count plus 1 to number of subsets. That should be there. So count plus 1 is to also count ones equals to 0, count ones plus plus continue. So we can just in dp into count plus 1 modulo mod equal 1 L. So that many, like for each of them we have these many choices. 6654. Oh, why are we getting 3? Okay, tp0, we have removed ones, right? We are only left with the remaining part. So remaining part we can either take to 10. So dp00 should also be 0. So it can never be 0 actually. 00 should be, can never be 0. Just be more. Like we have to take something. We have to take something. So p00 should be 0 because we haven't taken anything. Otherwise we have taken something. So we've taken something. Now we have these, for each of these per count one. The same. That would give the same thing. So like what we are missing here, but something definitely. N plus 1. Anyone has any idea about what we are missing? DPI mask is DPI error mask we are taking. Okay, so let's start from scratch, right? Let's understand the code. So we have first generated all the prime factors. That's good. After that, we are going through all the elements one by one. If error I is 1, that case we are just including count ones and continue. Otherwise mask equals to 0, duplicate prime is false, j equals to 0, j less than pf dot size, j plus plus, prime equals to, we are taking the prime factor out, and we are only considering the ones that has a single, that's a prime number itself or has is a multiplication of prime numbers. So count equals to 0, else if count is equals to 1, mask plus equals to 2 to the power j, because that prime factor is set. Otherwise duplicate prime is true. If not duplicate prime, error mask dot pushback mask a dot pushback error I, that's there. Okay, n is equals to a dot size dp. We are starting with n plus 1 to the power 10. dp 00 is 0. Dp I equals to 1, I less than 10. You can also check for the smaller case. d4 should give 6 and working for. So dp I mask and error mask minus 1 is equals to 0. dp I mask is dp I minus 1 mask. So you can either take or you don't take. So first of all, coming to the base case dp 00 is means that you have not taken any element. That should not be the case. You should have taken at least one element. So right, so that will be one case you are not taking. 00, we can always subtract minus 1 from that. So right, you are not taking any, so that should be one case. So this should be there, and dpn0 minus. So I believe it should be count once plus 1. Why is the answer reducing? I equals to 0. Same. Put have to do plus, that's same. That should not make any difference anyways. Minus 1 plus mod will do. But again, like we can either take it or we will not take it. So either if we take it, we have to find the number of ways, right? That's what we have to ask her to find the number of different. This you take it or you don't take it, you have a different subset I minus, and I must is dp I minus 1 or right. I'm not seeing any way, but yeah, like this would be the solution. So try it on your end. Maybe I'm pretty sure I'm doing some very stupid silly mistake, but I'm not able to find that. So yep, try this on your end, and yeah, I'll try to give you the solution in some way, right? But yeah, like I'm pretty sure that it should be a uh, simple issue which I've done in the all, and that's why it's failing working. But yeah, like this should be the solution. This should be the way it can be solved, and I think the logic also makes sense. So just try it on your end, and see like if you can figure out like what was the issue that I've done, you can like reach out to me and tell me that this was the issue. And yeah, like I'll see some way to actually like give you a working. All right, so it's already a lot, it's already like way past 10. So thank you guys for joining in, and I'll be seeing you in the next class.